Okay, today we're going to use Hess's law to calculate the enthalpy of formation for the reaction of nitrogen plus oxygen to make dinitrogen pentoxide. Now, normally you would use the equation, the heat of formation of the products, and subtract the heat of formation of the reactants. That's the most simplest way to do it. However, sometimes you don't have the heat of formation of the products in the reactants, and so you have to use some of these other equations, sort of like in algebra where you're solving simultaneous equations to solve for a particular variable. So what we want to do is look at these three equations where we do have the heat of formation of the entire equation, and you can rearrange them and add them together to get this equation. So this is our goal. We want to have a 2 moles of nitrogen and 5 moles of oxygen producing 2 moles of dinitrogen pentoxide. That is our goal. That's the end result. If you want to think of this as like an x and a y and a z, that's what we're trying to get. 2x plus 5y is equal to 2z. So we want to rearrange these. Now we can do a variety of things. We can multiply these equations by a number. We can reverse the equations if we need to. Whatever we need to do to achieve this goal. So let's look up here at the first equation. I notice that I have hydrogen and oxygen, and I have water. Well, the only thing that matches with this equation is the oxygen, so I'm going to move on because that's not very helpful. The second equation here, I notice that I have dinitrogen pentoxide, which is really what I want, but I also notice that it's a reactant instead of a product. I want it to be a product. So what I'm going to do is take this equation here, and I'm going to reverse the equation. That means I'm going to make the reactants products and the products reactants. So I'm going to rewrite it down here in the opposite order. So I have 2 moles of nitric acid I'm going backwards in this reaction, I'm going to do the reverse reaction, 1 mole of water and 1 mole of dinitrogen pentoxide. Well, that's helpful because at least I'm getting one of the product that I want on the right side. When I reverse this reaction, I also need to take into account that when the reaction goes in one direction, it's going to gain energy. When it goes in the opposite direction, it will lose energy. So when I reverse the reaction, I also need to reverse the sign because now I'm going to be gaining energy. Okay, let's look at this third reaction, see if this helps us. One thing I noticed about this reaction that I started using is that nitric acid is on the left. Nitric acid is nowhere in the final reaction that I want. So I want to get rid of this nitric acid because I know I'm not going to need it. And I notice that I have a nitric acid here. Well, if you think of this arrow as an equal sign, if there's a nitric acid on the left, you'll also want to have a nitric acid on the right because then they'll cancel each other. So I'm just going to take this equation and rearrange it, or I'm going to keep it in the same order, but I'm going to just rewrite it. Now I notice there's 2 moles of nitric acid here, and so I'm going to need 2 moles there. So I'm going to multiply this whole equation times 2 before I rewrite it. Now when I multiply the equation times 2, that means I want it to be done twice. Well, if I want it to be done twice, then I'm going to need twice the energy. So I'm going to rewrite it here. So 2 times 1/2 gives me 1 mole of nitrogen. 2 times 3/2 gives me 3 moles of oxygen. 2 times 1/2 mole of hydrogen gives me a mole of hydrogen. And then I have 2 moles of nitric acid. And then I'll also have to multiply the 176.6 times 2 as well. And I will get all right, we're going to double that. Okay, now let's keep thinking about what else we can do while I'm finishing this calculation. The third reaction we'll also have to use. We'll have to make sure that we put it in the right, whether it's forward or backward, based on what we want to get rid of and what we're trying to achieve at the end. Times 2. Okay, we get 348.2, as our heat of formation because we doubled it. Okay, now let's look at the top reaction. Hydrogen plus oxygen gives you water. Now there's not water in my final answer, so I'm going to try to do something to get rid of the water in one of my other reactions. So since water is in a product on this side, I'm going to make it in a reactant over here, which means again I will also have to reverse this reaction again so that I'm trying to get the products and reactants on the correct side. So I'll use a mole of water to make a mole of hydrogen and a half a mole. I know it's weird to see fractions, but we're talking about moles, so that's okay. So since I reversed the reaction, I have to reverse the sign. Okay, well, we're in better shape now if you look here. Okay, so we need 2 moles of dinitrogen pentoxide, and I notice that I'm only making 1. So I'll have to take this whole, let me just use a different color here, this one and multiply it by 2 so that I can achieve the correct number of moles of product. I also notice that my nitrogen doesn't have enough moles either for my product, so I'm going to multiply this equation by 2 as well and then rewrite it. So I'm going to go ahead and come down here and rewrite what I have. So I'm going to end up with 4 moles of nitric acid. I'm just going to kind of draw a line here because we're doing a couple different steps here. And it's going to make 2 moles of water plus 2 moles of dinitrogen pentoxide. And since I multiplied, I did this reaction twice, I'm going to need this to be done twice. So this becomes 153.2 kilojoules. And this is a positive. All right, let me rewrite this one down here. So 2 moles of nitrogen plus 6 moles of oxygen plus 2 moles of hydrogen will produce 4 moles of nitric acid. And my heat of formation now is 571. Oh no, I'm sorry, negative 696. Let me make sure I have my sign right down here. I think I left off a negative here. So this is negative 696.4 kilojoules. Sorry about that. Okay, and then I'm just going to look at this last one. I need to cancel this water with this water. And now that this water is doubled, I'm going to need to double this. So I'll rewrite this down here. I'm going to double the whole thing. 2 moles of water is going to produce 2 moles of hydrogen plus 1 mole of oxygen, and 285 doubled is 571.6 kilojoules. Okay, now that I'm here, I'm going to take all these equations and I'm going to add them together. But before I do that, let's start canceling. You can think of these arrows, or will produce signs, as kind of like an equals. So everything on the left we can compare to what's on the right to see what cancels. I do have 2 moles of water on the left and 2 moles on the right, so I don't need to rewrite that. I have 4 moles of nitric acid on the left and 4 moles of nitric acid on the right. I happen to have 2 moles of hydrogen on the left and 2 moles of hydrogen on the right. So let's see what we have left. Well, we have 2 moles of nitrogen, which is good. And then if I notice, I have 6 moles of oxygen on the left and 1 on the right. So you can think of this as if you had like a 6x plus something is equal to x plus something. You could simplify that by subtracting x on both sides in algebra, and you'll get 5x is equal to this. So we're going to do the same thing here. We're going to take and put 5 oxygens on the left, because that's where my larger amount is. And then the only thing I'm left here is 2 moles of dinitrogen pentoxide. So if you notice, this exactly equals what our goal is. We have 2 moles of nitrogen, 5 moles of oxygen, and 2 moles of dinitrogen pentoxide. So remember, when we're adding the equations, sort of like elimination in algebra, which means that I'll also need to add all these values together to get a final value. Now I have a negative here and two positives. When I add all of them up together, I get 28.4 kilojoules. And there is my answer. It looks very messy, but actually if you think of it, like I said, like algebra, where you have a system of equations and you use the elimination method, you're just adding them up and multiplying by what you need in order to eliminate different variables so that you end up with what you